Welcome to that session, Beautiful Workload Orchestration with Hashicorp Nomad. But before we get into the details, just let me introduce myself. I'm co-founder and head of the Enterprise Java user group in Austria. I'm a freelance software architect, developer, and I'm totally crazy about clean code and offering service in the Java and DevOps space. I occasionally do tweets when I especially write blog posts about Nomad these days. So if you wanted to follow me, here are the details. The agenda for that talk is just to set the stage. I'm going to do a recap on the Spring Boot deployment options and then jumping into Nomad that I'm going to explain and doing some comparison to Kubernetes. And then I will talk about how it looks and feels like doing a deployment to Hashicorp Nomad. And with that part finished, I'm going to switch to the IDE to talk and present some code. I do have a cluster prepared running on Google Cloud where I'm going to show you a Spring Boot app deployed to Nomad running as container workload. And I'm going to do a live deployment with the very same Spring Boot application, but this time packaged as a native workload, packaged using GraalVM. And given the time frame, unfortunately, I will not be able to do the live demo on the Java workload, but you're going to notice that after seeing the native deployment, there's not a big difference to doing the Java deployment. Yeah, so let's just have a recap on the deployment options we have with Spring Boot. Back in those days, we used to build Java archives, for example, web archives or enterprise archives, to deploy those to a servlet container just like Tomcat, or even deploy those to one of those heavyweight enterprise application servers. And then eventually, Spring Boot offered us to create those executable artifacts or archives with some embedded Tomcat or even Wildfly, so we could just run that archive without any server anymore. Then, like 10 years ago, Docker made containers very popular, so we started packaging our Spring Boot application as container images, and as Kubernetes got very popular, we started to deploy those containers to Kubernetes. And then very recently, Spring Boot gave us the support for GraalVM, so we actually could build a native image from our Spring Boot application, but still, since we wanted to deploy that to Kubernetes, we again packaged that as a container image. So it obviously, whatever we are doing, we just try to package everything up as a container so we could run it in Kubernetes, which happens to be the most powerful and probably most popular workload orchestrator. So what I'm questioning is here, is it really necessary that we do that extra pipeline step of transforming our Java application into a container image? And the question is, no, we really don't have to. There are other orchestrators around, and one of them is Nomad that I wanted to present today. And Nomad is actually able to manage all those types of workloads. So you can throw a container at Nomad, it's gonna manage that as your workload, but you also can just deploy an executable Java archive, and using the same technique, just a little bit of different configuration, you can manage that as well. And also, and that's very unique, Nomad can manage native binaries. So you build your Spring Boot application do AOT compilation, create your native image, and you also can deploy that to Nomad, and it's going to manage this workload as well. So it looks like this is a very flexible thing that is open source as well. So what is Nomad and how does it compare to Nomad? Given the complexity, of course, I'm not going to be able to go into all of the details, but I will be trying to do my best so you understand a bit what Nomad is about. So Nomad is basically a simple and very flexible scheduler, as I've outlined already. So you can deploy and manage your containers. But the unique point about this is that you can also schedule non-containerized applications. So this is a big difference to Kubernetes. So for example, it even runs on Mac hardware. Obviously, you can schedule containers, but it also would allow you to schedule KVM, QEMU, virtualized workload, and of course, it runs on Linux, or you can just deploy your Java workload. And it's very simple to actually run Nomad on-premise, and of course also in any cloud as you will. But I wanted to highlight, I don't want to bash on Kubernetes. I really love Kubernetes because of its power. So Nomad is an alternative, but it's not a competitor to Kubernetes. So if you happen to already run a Kubernetes cluster, you're just fine doing that with your complex applications that need the power of Kubernetes. But for applications, for workload, where you don't need that complexity and power, you just can run your Nomad cluster alongside Kubernetes. So this is really not about bashing on Kubernetes. I love Kubernetes, but I also figure out that Nomad is just kind of much simpler in some way. So let's look at the components that you get with Kubernetes and Nomad. When you have a Kubernetes cluster, you get quite a large set of building blocks that Kubernetes is made of. Nomad, on the other hand, is coming with a much smaller set of core blocks, namely automated scheduling. So Nomad is taking care, so you can schedule your workload, you can instantiate your containers or Java workload, so it runs on your worker nodes. Also, it comes with self-healing capabilities. So, for example, if your workload gets unhealthy, Nomad and, of course, also Kubernetes both try to do their best to keep that instance up and running. Also, you have rollout and rollback capabilities. So you roll out the new version of your application, and in case you figure out, okay, it's not really working as expected, you just can revert and just do a rollback of that application. And of course, there's also some support for storage orchestration. So this is the Nomad core. Everything else is just optional. So if you happen to need secret management, then, for example, you could plug in Hashicorp Vault, which you probably know. Also, if you happen to need service discovery, so you wanted to register your workload as services and then do service discovery, then you could plug in an extra component. For example, you would go for a Hashicorp console, and the same goes for autoscaling, load balancing. For example, for load balancing, you could use the popular load balancers Fabio or Traffic that I will be using for that demo. So it seems with Nomad we are getting something that is much simpler than Kubernetes is. So obviously then it will be much simpler to manage when you have to take care of a cluster setup. I don't know who of you guys is running a Kubernetes cluster, but it can be sometimes really tedious. So yeah, let's look at the next key differentiation. Kubernetes is strictly built for running just container workloads. So a worker node needs some container runtime to execute your workload. Nomad has been built with a different focus. It has an abstraction which is the task driver, and using that task driver that is pluggable, you can run many different types of workloads. So there is built-in a support when you start the client node. It does some detection, and to the right you're seeing a screenshot or a snapshot from the client UI, and you see the client node detected that obviously a Docker runtime was installed and that on that node, so it reported Docker as healthy task driver option. It also detected that there is some Java installed in that node, so we could actually schedule Java workload as well, which I'm going to show in my demo. And also we see those exec drivers which enable us to run native images. So basically you can run any native image that is available on that client node. For example, that could be a Spring Boot application that you transformed into an image using the GraalVM and its AOT compilation. What we also see here is QEMO. So QEMO is not installed on that machine, so we potentially could also manage KVM virtual workload. But it's not limited to those drivers. There are many more plugins provided by Hashicorp, and there are also community plugins, for example, like Podman. So if you're in the Red Hat space, then you might prefer Podman over Docker, and you could just enable that plugin here as well. So this is really very unique about Nomad. Hashicorp has defined something they call the reference architecture, which is just a best practice on how to set up your cluster. And this kind of shows the components that you need in such a cluster. So for the control plane, you need those Nomad servers. In a data center, you can have 3, 5, or a maximum of 7 servers that take care of the cluster management and scheduling your workload. In order to set up those Nomad server agents, you just need a single binary, which is the Nomad binary. So for the workload, then you need those client agents, which are instantiated from the very same binary. So you just have a single binary, and that can take on the role as server agent or as client agent. And those Nomad clients are then those nodes that actually execute your workload. And for those, you can actually have as many as you want, I would say. And I'm giving you a couple of numbers later on. So basically, those green building blocks make up the Nomad cluster. If you happen to require service registry, you would potentially connect that cluster to some console cluster, and for that you just would have to additionally install that console client to the server nodes and also the client nodes. So the Nomad servers can actually register workload as services, and clients can do service discovery. So basically, this is what makes up a complete Nomad cluster. And the key point is it's just a single binary. So if you wanted to run those agents, you would just invoke one of these commands, passing either the agent, the server flag, or the client flag, passing in some configuration if needed, referencing some HCL configuration file. But the beautiful thing about Nomad is it is extremely developer friendly. So if you wanted to set up Nomad on your local machine, you could use the very same binary, Nomad, just pass the development flag, and you would get an agent process taking on the role of server and client. So you basically, on your local machine, on that Mac, I could potentially use that to develop and schedule my workload. So this sounds like it is very efficient in terms of management and execution. So, and actually to prove that, back a couple of years ago, Hashicorp together with AWS did the so-called 2 million container challenge. So in the Kubernetes documentation, you can read up on the limits of Kubernetes, which are, these are the limits that are given by the architecture and the way Kubernetes is working. So they are saying they are restricted to 5,000 nodes and you can run 300,000 containers. So this is their limit. Nomad, on the other hand, can size clusters up to or exceeding 10,000 nodes. So that's already pretty big. But in that container challenge, they actually tried to schedule 2 million containers on 6,000 hosts, and they've been able to spin up that cluster in just 22 minutes. So this is really impressive, and honestly, I would like to be in the business where I had to schedule that infrastructure. Yeah, if you are interested in the details, here you find the documentation on that. So basically, with that, really, why did you want to use Nomad, or why would you even stick to Kubernetes? So basically, if you're tied to strictly running containerized workload, you're probably very good off with Kubernetes. But in case you have to run non-containerized workload, such as Java, executable archives, or native images, and don't want or can't convert those into container images, then you might look at Nomad. The same applies to like your operational overhead. If you have just small budget or small teams that need to manage your clusters or setup, then it's definitely much easier to do that with Nomad. Kubernetes is way more expensive and complex and a little bit more challenging to keep it up and running and do upgrades and so on. Also, if you are bound to running your workload on-premise, then you also might be better off with Nomad. Kubernetes probably is a good idea to just use managed services in one of the cloud offerings. So, and with that, let me introduce you to the demo that I'm planning to show. Well, I'm planning or have prepared a cluster that is following that reference architecture, and I'm going to show how to run container workload and native workload side by side within the very same cluster. So the setup kind of looks like this. So I have those three, I do have a cluster set up with 3 server agents and also just 3 client agents as shown here. These are connected to a console cluster, so I can exercise service registry and service lookup. I'm going to deploy that different variations, containers, native, and Java. Actually, I'm not going to do Java because I may run out of time, or I just wanted to keep some time for enough questions and answers. So I'm going to deploy those different workloads into different namespaces. So like Kubernetes, we also have the option like to set up isolated namespaces which are separated from each other. So there are no conflicts with naming and so on. So I'm going to have a namespace Bootiful container for keeping my container deployment, and I'm going to have a dedicated namespace for deploying my GraalVM native image-based workload. And all those workloads are then handled by, or actually I have added traffic as a proxy to a cluster, so client requests are actually routed into that cluster or that workload instances. So that is basically the setup for that. Yeah, the first part, that one is already up and running because it takes a little more time to actually start up. This is the demonstration of the container workload. You are going to find all the source code in my GitHub repository in different branches. You're going to find that in the branch Bootiful container, and that workload, that application is based on Spring Boot 3. It's running on JDK 17. It's, yeah, I would say kind of hello world, very simple application using some Spring Data REST to implement a REST API that is connecting to a Postgres database, and we're going to deploy or schedule that application as a container workload, and also the database is running as a container workload. So yeah, this is packaged as an executable Spring Boot jar, packaged as container. Its startup time is about 12 seconds, so it's really a very simplistic application, and that startup time is due to JVM startup and some startup time for initializing that Spring Boot application. Then next, this is the part that I'm going to demonstrate live, connecting to my cluster in Google Cloud. This is the demo for the native workload. So the very same application this time has been converted into a native image using the GraalVM AOT compiler. So it is packaged as AOT compiled native Linux binary, which has been uploaded in my build pipeline to some Maven repository. And yeah, just to demonstrate the efficiency and yeah, the fast boot up time or startup time, this is just 0.5 seconds now. Yeah. Unfortunately, in my session, there is just not enough time to really go into the details of how to build a native image. But if, or in case you're interested in it, and I really can recommend that session, just join Alina's session, which is starting at 12 in the auditorium, and she's going to show how it looks like, how it works to actually convert your Spring Boot application into some native image. Yeah, that's the part. Yeah, I'm gonna skip that because I'm not gonna do that one, but I'm just gonna explain what it would actually look like to run that as a Java workload. In case you already have questions, just feel free. I think we are a pretty small crowd, so I'm even happy. But in case it's easier for the ones managing the microphone, we can just do that in the end. And by the way, the slides are already online on my SlideShare that you can just download as well. And yeah. So let's just now switch to the IDE. Actually, just let's first look at the cluster that I have set up. So let's check, yeah, I still have connectivity. That has been the risky part about preparing that one because, yeah, with such a live demo, things can always like break or go wrong. So what do we have here? When you install Nomad, also get like a pretty decent, nice UI. And that is showing what we have deployed here. So basically, you see I have those 3 servers running that are implementing the control plane. I do have those 3 clients that I mentioned. So this is really following the reference architecture. And if you're just drilling into the view of one of those clients, we really see that upon start, and actually it's polling that information following some schedule. So we are really seeing that clients have those plugins for the task drivers for Docker, native images or native binaries, and Java as well enabled. So exec is kind of a task driver that tries that is only available on Linux, and it tries to kind of run your application in a sandbox. So it is using chroot, while as raw exec does not do that. For example, on a non-Linux machine, you would have to use raw exec. So you would not get that sandbox. And by default, the plugin for KVM virtualized workloads is also included, but I just happen to don't have that installed here, so it's just grayed out. It has not been detected. And otherwise, you are going to find lots of attributes that you can use for assigning workload to dedicated nodes and so on. So what else do we see here? When we speak about deployments, we speak about jobs, and I'm going to explain in a couple of minutes how it really looks like coding or implementing such a deployment. So I do already have that application running as container in that namespace, Bootiful container, and with that, as I said, I also have console set up here, so all the components that are already active are registered here as service. So even the Nomad servers and clients get registered up here. Console itself, traffic, the load balancer that is already installed to the cluster shows up here, and of course also my application. So you see those API instances and some database instances being registered here. So let's now really jump into the IDE and let's look at some code. When it comes to implementing a deployment, you basically write a job deployment descriptor. And this descriptor is using Hashicorp's language for configuration, which is the Hashicorp language, or just HCL. So this is why we have that extension HCL. And that just kind of looks a bit like JSON, but I think the best about this, there is just no YAML. Anyone who really loves YAML? No. It's kind of okay, but yeah. Yeah. So basically, when it comes to deployment, we just describe such a deployment job. We just name it. We can just assign various attributes, for example, selecting data centers. So we actually can target different data centers or even regions and so on. We can select from a set of job types. This is of type service, as we just wanted to deploy classical application workload, and this is type service. And then we can structure our deployment descriptor using groups, which we see here. So basically, I have defined two different groups up here. The first one is that DB group that obviously stands for database, and that just takes care of deploying that Postgres database. In this case, this one is, yeah, just let's drill into that one so we can see more details. It's going to manage that as a container workload. So our workload within that group is defined as a task. So within a group, I can define multiple tasks. For example, I could have my application within a group, but also could add some sidecar, yeah, something that you probably know from Kubernetes. So I can actually just group multiple tasks or workload elements, and that would get scheduled as a group on a single node, yeah. So they are always like very close to each other. And for that database task, I have decided to schedule that using the task driver for a Docker container, but also could like use different driver types here, as I will use later on. So as this requires a Docker image or a container image, this requires some task-specific or driver-specific configuration. So basically, I just need to reference a container image, and that will be downloaded automatically, as you would expect, using some container registry like Docker Hub or whatever. So for the rest, let me actually switch to my Spring Boot workload, because I can show just a bit more details here. So this group API is now responsible for scheduling or describing my deployment of that Spring Boot application. And here I already see one attribute, which is the count attribute, which I can use to express how many instances of that task I need. For example, if I wanted to have one instance of that Spring Boot application allocated to each of those worker nodes, I have 3. So I have set that variable to 3. So basically, with HCL, you also can use variables. So you can just make your configuration a bit more flexible. So let's look at that configuration for that task deployment. Again, we have the driver attribute. This is now expressed as a variable, as I'm going to switch that to native with the second part of the demo. And yeah, this time you also see, okay, I might need some authentication, because this is downloading from my private container registry running at GitLab, and yeah, that just needs some credentials. So this is the part about configuring the Docker driver. And like with Kubernetes, you also can assign resources to your workload, to your tasks. So for example, if you wanted to restrict the amount of memory allocated to that task, then you could do so here. Also, you could like assign CPU amount and so on. So you have many options of allocating or assigning resources to that application. And then usually we happen to configure application using environment variables, and that is taken care of by using this env block. Yeah, I think this is very straightforward, but this is just limited to static configuration, static environment variables that do not change their value. If you needed a more flexible configuration mechanism, then you would go for those templates using that template block, and that is actually using console templates, in case you heard about that or know about that. And that is very flexible about dynamically setting up that environment by referring to other variables. For example, like here, Spring Boot allows me to define the server port. When I schedule that, Nomad, of course, is going to randomly select a port, and I wanted to just assign that here. But this is not all. For example, my application is actually connecting to that database that will be scheduled as a container as well, and it will be registered as a service. But I'm going to show how service registration looks like just in a couple of minutes. So basically, I can use one of those functions from console templates to actually do service discovery. So I'm using range service to ask console, give me the IP address and the port that has been registered for that service, continuous delivery DB, and then some suffix for the environment. So this is very flexible about having a dynamic configuration. And whenever one of those variables is actually changing, then that template, or actually that file that gets rendered from that template, is re-evaluated, and in case one of that arguments, one of that variables changes, that workload will be restarted. So you just need to modify one of the variables, and Nomad is going to take care of updating the application. So with just some delay, you have that configuration applied to your workload. Okay, then I mentioned service registration. In case you wanted to register your service that you're instantiating or implementing here, you just wouldn't use the service block. So you just would assign some unique name. Here I'm also using that environment, for example, Bootiful container or Bootiful native, which is my namespace as well. And I would just select console as a provider for that service registry, which is the default anyway. As of now, we have Nomad 1.5. In 1.4, another option was added here. So if you don't need all the complexity of console, you can just go for Nomad as service registry. So it has built some basic capabilities that you can use as well. And then you just use the value Nomad over here. So that's about services, and you also can define a health check. So for example, in this case, I'm just using Spring Boot Actuator, so I can periodically check on the application health. So this is now about the deployment descriptor. So I think that is very convincing. It really looks much simpler. You have most of the information just in one place. You don't have to deal with like dozens of YAML files. Yeah, so I consider that much simpler. Yeah. So when it comes to deployment, once we have run that, we actually see that deployment. So we get those task groups. We have specified that we have 3 instances of that tasks for the API. We have 1 instance, 1 container for the database. And when it comes to sending that workload to the worker nodes, this is done through allocation. So an allocation is basically assigning a task to a client node. So this is I think in Kubernetes this is like the concept of pods. Yeah. So let's now talk about a native deployment. So that looked pretty straightforward, you're defining that deployment descriptor, right? So I'm now in that Git branch, Bootiful native, that just has some minor modifications to the deployment descriptor. Everything, almost everything that I explained is just the same, with the exception of that driver configuration. So basically this time, for deploying that Spring Boot native application, I just set that driver attribute to exec, so it activates the support for deploying or running native Unix or Linux workload. And this time I don't need to download from some container registry. I basically need to download that native binary from that Maven repository where I've published that artifact. So for that application, I have one pipeline that is taking care of compiling that, doing the AUT transformation, and publishing that native image in a Maven repository. And I'm just using that artifact block here to perform that download. But from the point of Nomad, this is just a download URL. It doesn't have a notion of Maven at all. Yeah, so it could be just any URL that happens to provide that image to be downloaded. And for the execution of that native image, I just would specify the command, and that would just be the file name of that binary that has been downloaded in that artifact block. So pretty straightforward, and it just happens to be downloaded to some well-known directory. But the rest of that deployment is just exactly the same as I have explained it before. Yeah, so let's just do that deployment now. Let's get back here, refresh it. So you see there's just that 2 namespaces, Traffic for the load balancer and Bootiful container in place. So I do have the web page for that container application already up and running. This is just exposing a simple REST API. I also have that HAL Explorer live here, so I could just send some requests using a UI, and it just gives me something that I can actually show. Showing some kind of UI is always nice to show. It is actually working. The workload for native images is still not deployed, so I'm not gonna get some useful response here. So let's look at the deployment part. So, okay. Let's actually just start that because it takes a while. I have prepared that script that performs that deployment. I'm just going to start it as it takes a couple of minutes. So it does its deployment, and while it is running, I just can explain that command to you. So it is running, and I'm running it in blocking mode, so it's actually updating me about the progress. So it's showing me, yeah, I have requested like 3 instances, and just look at that one. I think I'm already getting close to the end. So basically I just run the Nomad namespace apply command to create that namespace. I run that command Nomad job run, and I would just pass in that configuration file then. And that's just all. I don't know how many minutes I still have. The deployment is still running. I started my timer a little bit too late, but I think I still have a couple of minutes. Yeah, let's just go to the UI. So I do see that new namespace over here. It just still is taking a while. So all the nodes actually get their healthy instances of that API. Yeah, but as we wait, I think we actually could start with Q&A. So do you have any questions that I would be happy to answer? Yeah, there's one question.
I see you can set CPU and memory constraints, right?
Yeah, correct.
I might know how they can be enforced with containers, but how does it enforce them with native executables and Java?
I have not looked into the details how they implemented that. Okay. So I'm sorry, I really cannot give you an answer on that. And anyway, this is really very new, so I've just recently added that played with that native support as Spring Boot came out. Yeah.
Okay, thank you.
When is the cutoff when you prefer using Kubernetes instead of Nomad if you start your cluster creating with Nomad? Or what is your experience?
What do you mean by cutoff?
Yeah, Kubernetes is quite more complex and more powerful, but if you start to raise your cluster with Nomad, when is the point you say, okay, now I have to switch to Kubernetes, or is there no point?
I think this is really very hard to tell because it really depends on, I know this is a stupid consultant's answer, it really depends on the requirements you have, yeah. So I don't think there is a very clear answer to that, yeah.
Did you ever get to this point?
No.
Okay.
I mean, what I experienced, I started with Nomad like 4 years ago. It was still not 1.0 and it was extremely stable. And I had just a very small team of developers, and actually we as developers, as DevOps teams, we just asked ops, okay, kind of give us those machines and we are taking care of that cluster ourselves. And it was really extremely simple to do that. And that's something that is just a bit difficult with Kubernetes. Usually you are asking for developers with CCAT certification or so. So it's really a matter of your budget and team size, I would say. I think that's the most, I think that's the argument that is most driving that, probably that decision, and the possibility of running your workload, you're running non-containerized workload, yeah. Yeah. I hope that kind of gives you an idea. Yeah.
Thank you.
Thank you. Any more questions? There is one more.
Do you have various clients as consultant who prefer Nomad?
Yeah, that's a bit difficult. So far, I've just one client, yeah, who is using that, yeah. Especially for that constraints. They just had a very small team, literally no budget, like a startup, and yeah, as I said, in many times you just don't need that complexity of Kubernetes. It's more or less just like blocking of you of progressing fast, yeah, because you have just to have collect so much knowledge before you can actually start it. And I had that cluster up and running in like a couple of days. And there is like Terraform available from Hashicorp that you can use as starting point. I used to start with some Ansible roles. Unfortunately, they are not maintained very well anymore. But you still can use that as a starting point if you happen to use Ansible yeah. And usually Kubernetes, I always say, just don't try to run it on premise unless you really have very experienced DevOps or operations members. So you're better off probably with paying something or actually a lot to one of those cloud providers. Yeah.
So instead use Nomad.
Yeah, correct. That was the message, I guess, of that talk. Yeah, thanks.